So the Atwood machine is created by Atwood, and it's pretty much a device that kind of helps people study classical Newtonian physics. But pretty much what it is like it's a system with pulleys. So what's nice about pulleys is that it changes the direction of force, and we'll kind of go through that with here. And by doing that, you could have different angles and different things. In real life, what it could be useful for it, and these aren't real Atwood machines, they're just real applications of the same concept, is elevators. So elevators is a classical, I guess you could call it an Atwood machine, because you have two masses on both sides of a pulley. So here is your classical, and not classical, but here's your example. And you have a pulley up here. You have a string to a mass on this side, a string to another mass. And these masses are pretty similar in I guess in mass and weight, so that it's really easy for the motor up here to move up or down. Elevators or these are kind of work the same way. You have two carts that have the same mass, so that it's really easy for the motor up here to twist them, and the one trolley will go up as the other trolley goes down. So it's pretty straightforward, and typically that's what we're going to do for an Atwood machine, is problems like that. So right now, let me show you. Here is your classical machine, and the reason why they use this is because if you have masses on both sides, the total acceleration is going to be much smaller. So let's say you had 10 kilograms here, and then let's say 50 kilograms here. So you want to know what are the forces acting on it, and pretty much in the end you want to know, find the acceleration, the total acceleration on the whole system. These two masses are attached to each other, so if this one has acceleration of, let's say, 10, the other one's going to have to as well, because they're connected together. Now, before we get there, let me kind of break down all the forces acting on it. So on this one, you have force of gravity on the 10 gram one. So let's just multiply by 10. So 10 times 10 gives you 100. And I'm not going to worry about units yet. On the other side, you're going to have the same gravity as well. Force of gravity, and this is 50 times 10. So this one's going to be 500. So you have a 500 force of gravity on this side, 100 force of gravity on this side, and they're both connected by tension. This is the same string, so this T is the same for both, so the tension is the same for both of them. So the key is, okay, so what is the total acceleration? Now in real life, there's some friction here. And in real life, there's air friction as well, but we're going to pretend that there is none, so no friction in the pulley at all. So this is a free flowing system, and you're going to have the following. So in a problem like this, since you have multiple directions, they technically don't cancel out, or in this case add together, and I'll kind of explain what I mean by that. This force of gravity is down. This force of gravity is also down, but they're not helping each other. Since they're attached to the same string, as this one's pulling down, it's tugging against the other one, and the same thing's happening from this side. This one's tugging down on this tension, so it's also tugging on that one. So they're both using this rope to pull on one another. They're both going to feel the force from the other person or the other mass. So in reality, it's just one linear continuation motion. So here we're going to use a tool called direction of motion. We kind of did it already with centrifugal force, but we're going to do it again here. Now, just looking at this, I'm just going to make an assumption. It might not always be true, but I'm going to make an assumption right here. This force of gravity is bigger, so I'm going to assume this object or this system is going to move to the left. So what I'm going to do is I'm going to do direction of motion. So the right side is going to go up, while the left side is going to go down. Now this is important because I want to make all the signs equal to each other in relationship to what they are. So if this is up, then this is going to be positive because it's in the same direction of motion. This is going to be negative because it's in the opposite direction of motion. On the other side, this is in the opposite direction of motion, so it's going to be negative, and this one is going to be negative here. So it's up to you how you want. Oh, I messed up. This one's positive. It depends how you want to do it. I usually like doing it that way. So now you'll notice that the forces of gravity is opposite. Tensions cancel out. So if you do sum of all forces in this whole system, you have Fg of the blue plus tension minus tension plus Fg of the pink. Now, make sure I got my signs correct. This one's negative, this one's positive, this one's negative, and this one's positive. It's good. You'll notice, like I said in the very past, tension, when you look at the whole system, it's going to cancel out. So you're just left with sum of all forces equal to Fg of the blue plus Fg of the pink, which is equal to Ma. This is negative, and I'll just plug in the values right here. So negative 100 plus 500 equals Ma. So that's 400 newtons is equal to mass, and you're going to add all of it together. So 50 plus 10, because it's the whole system that's moving, and you want to find the acceleration. So then it's 400 newtons equals 60A, or A is equal to 400 divided by 60, and that should give you your acceleration. And you get 6.6 repeating meters per second squared. So that's kind of example how to solve the problem. You look at the whole thing as a whole. Okay, so that's kind of that example. Let's do this one. So here it's going to be a little bit different, but we could be similar as well. So let's say this mass right here is 10 kilograms. This one is 20 kilograms, and we want to find A. We're going to initially assume that there's no friction just to make life a little bit easier. Okay, and this one's going to be a little bit different, right? The force on this one will be this way, force of gravity, and that's going to be 200 newtons. You're going to have a tension up, and then in this case a tension to the right. Here you have a force of gravity down. In this case it'll be 100 newtons, and then you're going to have force normal. This is on a surface, which is going to be 100 as well. This one's going to be negative, this one's going to be positive. Now in this case, when we look at what the motion is, it's going to be going to the right here, and then it's going to be going down. So this is my direction of motion. And like again, I'm going to use this to kind of determine my sign. So in this case, it's going to be positive down. So here it's going to be positive, here's going to be positive. Now when we look at here, that makes this one positive, this one negative, this one positive is in the direction. But here you'll notice that both Fn and Fg are perpendicular to the direction of motion, so they don't affect it at all. So all it is sum of all forces is just equal to positive tension minus tension plus Fg. And that's it, equal to Ma. You ignore the force of gravity here because here is perpendicular. That's the case, the tensions cancel out and you're just left with Fg is equal to Ma. Fg is 200. Now the trick is the mass. Even though this Fg is not being used, it's being moved. So you want to add both masses together. 20 plus 10, acceleration. So then it'll be 200 divided by 30 will equal your acceleration. And in this case, it's going to be 200 divided by 30. So that it also ended up to be 6.6 repeating. So I don't know what's my knack with that, but I picked the same numbers to give us the same kind of thing. So there it is. So hopefully that makes sense. The problems aren't hard. You're just breaking it apart. Now, what happens if there is friction? So let's say here, instead of rolls, we just have a box. So there's going to be friction. Mu s, let's say, is 0.5. Mu k, let's make up as 0.3. And we want to find out, okay, what's going on here? So same thing. Let's do the same masses. This is 20. This one's 10. So the forces are going to be the same. Fg is negative or positive 200 here. Tension is here. Tension is here. Here we have Fn, which is positive 100, and then Fg, which is negative 100. Now, before we move on, we need to find force of frictions. They're static and kinetic. We don't know which one is. We need to figure it out based on the mu's. So force of static friction is 0.5 times this one, 100. So force of static friction is 50 newtons. So 50 newtons are going to pull back this way. Now, which one's bigger, 200 or 50? And the answer is 200. So this thing's going to start moving, right? So it's going to move. So then we want to use 0.3 times 100. So kinetic is 30 newtons. And then so instead of 50, we're going to use, instead of 50, we're going to use 30 because it's kinetic. So here, sum of all forces, we're going to include friction this time, negative 30, plus tension minus tension because they cancel out, plus 200 equals MA. And then you have 170, and the T's cancel out again, equals MA. And then M is the same as before, 20 plus 10. So in this case, it would be 170 over 30 will give us A. So 170 divided by 30 will give us 5.6 repeating meters per second squared equals A. So with friction, it's just one extra step, then you get that. Okay, one last thing that I might ask you is find tension. Okay, so how would you do that? Well, if you use the whole system, it always cancels out. So that's not useful. Using the whole system is nice because that way you could find A. But if we do this, if we look at just by itself, we could figure out what's going on. So what I'm going to do is if we want to find tension, we just want to focus on one of the items. So we have here sum of all forces of just this item is Fg plus T, so they don't cancel out. One of them has to be positive and one of them has to be negative. It doesn't matter which one, as long as you know in your head. And this is equal to MA. Now, we couldn't start off by this because we didn't know what A was yet. So we need the whole system over here to figure out A. And then once you have the system acceleration, you could isolate individual ones. So here you have 200 plus T equals mass, and this time it's only one thing, so we're only going to use 20, and then the acceleration here is 5.6 repeating meters per second squared. Now, the only caveat here is you need to be careful what's going on. This acceleration ended up to being positive, and it was positive because it was in the same direction of motion, right? There's DOM. Because of that, that's why this is. So when you're doing this, even though it doesn't matter what sign it is, it needs to match. Acceleration is this way. So if you're going to make this one positive, acceleration is also positive. So this is positive, okay? So you have 200 plus T equals 20 times 5.6. And then you're going to subtract 200, so 113 minus 200. So here tension is equal to negative 86.6 repeating. Okay, so solve for the whole thing for A because then the tensions cancel out. But if you want to find tension, you have to look at individual properties.